the quarter now, and let me hand off the control to you. All right, you are the boss, man.
Okay, just need some peoples.
Yeah, it's better with people.
Crucial ingredient.
Yeah, okay, that's that thing.
Okay.
Oh yeah, that was another problem. Putting the damn things on.
That's not doing it, mate. Is that a bit odd?
I'm gonna.
All right. So today's lab is going to be doing the thing that was just done in the lesson. Let me get that up a minute. But we're just putting it together and actually executing it. So with that in mind, the take home is almost exactly the same. And the lab itself is quite small. So what we're going to do is we're going to do it together. And we will get as far as we get. I suppose I can remind you that it's in your best interest to get further so you can know what to do in the homework. But yeah. So we have some data in the form of CSV. The link here worked just fine for me. Looks like this. And what that data is it's a bunch of measurements for watersheds and rivers and stuff like that. So they can try and predict flooding and all that fun stuff. So we're going to make a predictor response type model so that hopefully we can have something that'll let us predict in the future. So let's start that. First thing we want to do is we want to read the CSV as a data frame, and then we want to explore that data frame. And we already have a skeleton of what we're wanting to do here. So import packages. What do we want to import? Pandas. Yeah, that's probably a good one. And yeah, doing the moniker is probably good. Anything else? Requests, we can do that. Are we good? Are we going to need anything else? Okay, then. All right, let's read the data file. We want to have a data frame. And in order to get that data frame, we need to do something. So how can we get the watershed CSV into a data frame? So you can either, any of the following are acceptable answers. You can give me the actual syntax. You can explain what you want me to write. Or you can tell me what we might need to Google, or you can tell me where I can go that we've already done this and we can copy and paste it. I downloaded CSV also. It's over here. But we want to get this CSV into a data frame, and we'll call that data frame data. So how do we do that? Yeah, we can use the pandas method of read CSV. And the watersheds file goes there. All right. Well, let's make sure we actually have it. What can I do here? I can do data. Okay. All right. Hey, we at least have data. It may not be correct, who knows, but at least something's there and it looks right to me. Okay. So the next thing we need to do is summarize the contents and describe that in a markdown cell. Okay. That's something we can also do. What is a method we can use that would get us the information we want to look at? Head's already given us a lot of it, but there's another one that we can use that would get us like the means and the standard deviation and stuff like that. Yeah, describes a good one. Okay, so based on that, we can go ahead and describe what we've got. So there's three things that I think are really important. So let's see if we can list those. What would you think are the important things about this data frame? So we need to briefly describe the data frame. How are we going to do that? other than with English. Sorry, the dogs are going nuts. But come on. So the question is, how would we describe this data frame? What are the important parts? What is characteristic about this data frame? What are the things I need to say in order to describe it accurately? Is it an integer? Is it blue? What is important about what we can see? Chris is the MVP today. Yeah, so you've nailed 2 of the 3 things that I think are really important. And those are the number of entries. The other one would be how many columns there are, and then what the type of those floats are. So, is what I have here correct? And if so, is that good enough? Think the standard deviation is important? Yeah, I agree it's important. I don't really think it has to be in the description because I don't see anything unique about it. Like, if I did notice that the standard deviation, at least 2 of them were the same, I would probably point that out. Or let's say the mean was a whole number instead of these floats, as I would expect, I might point that out. You know, it's a subjective thing. But there's something that's not correct about this. So let's go through it. Does the data frame have 92 entries? Seems like it. Does this data frame have 7 columns? I don't know. Does it? There's 6 columns of data right here. Yep, there's only 6. There's 7 right here. So how is that possible? Why on earth would, when we do the describe method, we only get 6 of the 7 columns? You are correct in that the station ID is just an ID number. And it's not that it isn't important. It's that it's not a float. This is actually Oops. It's a string. So this first column is a string. Well, it's a column of strings. That's why it doesn't appear here, because you can't take the mean or the standard deviation or the minimum. Well, I guess you can take the minimum of strings. So this is not entirely correct. So if for some reason you decide that this is what you were going to copy and stop paying attention, it would be wrong. So we have 7 columns where the first is of type string and the rest are floats. And I think that's good enough. All right, moving on to step 2. We need to make a data model using TDA as a predictor of t-peak. And this is the formula we want to use. Okay, we want to plot the model and the data on the same plot. Report the values. All right. So where do we even start here? What does this mean? How do we make a data model? Have we done that before? Or do I need to look it up? What the heck does that mean? Don't we need to define a model first with the equation it gave us? I'm not sure if I'm understanding correctly. Now, Robert says we would have to define a function. And yes, we do. We need to define a function that can do this. That's simple. At least it looks simple. Define our I'll call it a predictor function. Okay, so in Python, in order to define a function, you need to use the def keyword. You need to give it a name. And it doesn't have to return something, but here we're going to want to. Okay, so I've laid out the basic syntax of what we want to do. What do we want to call this function? T-peak? Okay, we can do that. All right. How many arguments is this function going to take? Three. Oh, interesting. What are they? What arguments is this function going to take? Apparently there are 3. B naught, B1, and TDA. That is correct. So we have B naught, B1, TDA. Alrighty. Now what do we want to do with these? We want to transform them in some way and then give them back. So how do we want to do that? Do I just want to do this? Yeah, that's well, almost. You got an equal sign there, but almost. So that's just a typo, I'm assuming. V1 times TDA. It's not a trick question. It's right here. Not really anything complicated about it. Okay, so now we have a function that we can apply to our TDA stuff and get output back. Okay, so we've defined a predictor function. Cool. What's next? So we need to make a data model. All right, we have a predictor function for that. At some point, we have to plot. I know that. Is there anything else that we know we have to do? Well, we have to make a data model, but we don't really know what that is. That's the whole task. Is there anything else that we need to do in order to make a data model, or are we done? So since I heard someone just join, we are trying to make a data model using TDA, which is a column in our data, as a predictor for T-peak, which is another column in our data. We've gone ahead and made the predictor function, and we're trying to figure out what else we have to do. So far, we are of the mind that we're done. So that'll be that, I guess. Seems simple. Are we actually done though? Do we have a model plotted? So as I said before, it's completely acceptable to either tell me what to Google or where I can go to something we've done previously that would have the answers we need. You don't have to just barf the answers up on the screen, but I do need to know where to look. We could look at lab 15. Yes, we could. I think I had 22 up for that, but let's see if there's something in here that's nice. Okay. This is plotting some stuff. That's nice. Hey, there's a line chart. So here's a question. What's PLT? Matplotlib. Ah, okay. Do we need that? I think we need that. So let's get it. Alrighty. I'll run that just to make sure. Okay, so we know we got to plot something. I don't know how, don't know what. But before we worry about plotting something, don't we need something to plot? The data is already there. That's nice. I can plot the data. But I need to have a model. So, oops, not that one. We're going to be plotting stuff. And our data is already here. So we've got our TDA and T-peak data. That's cool. That's there. We could plot that right now if we wanted to, but we also need a linear model that's approximating this. That's why we made that function up there. So how am I going to get this linear model built? Did we do that in an example? Or are we actually in a lab trying to do something we don't know how to do? Is this something we have never seen before? I'll give you a hint. The answer is no. Can we look in lab 14? We could, but I'll tell you this. You only recently learned how to do this. In fact, very recently. You guys are making this difficult. 18 or 22? That might let us know how to plot what we want. But at least you tried, and I appreciate the participation. But really, we just need to look in the lesson. So today's lesson was all about this. So here we have what we're wanting to do. Goes all the way through it. We've got some time measurements and some speed measurements. And what we would like is to, let's see, oops, get rid of it. So I've got my plot of time versus speed. I've got time down here and speed over here. So you'll see it looks something, I don't know, like that. That's the data. And what we want to do is to approximate a formula that's going to be a good fit for this. Now, if we're using a linear approximation, that's fine. Or we might be using a quadratic approximation, that's fine too. Might go that way. But that's what we're trying to build, the thing in blue. So in order to do that, what we're going to do is we're going to make a linear system. This is just a matrix. And then what we'll do is we're going to use the matrix solve method to figure out what might be the best linear model to apply. So that's what we're doing. It's actually all right here. We're going to build our data model. We're going to actually evaluate how good the model is. We're going to plot it. And then we're going to display it. Okay. So how are we going to do that here? How are we going to do the thing we did earlier in the lesson, but with different data? Well, let me ask it this way. We've got our data of watersheds, right? Looks like this. What if I wanted to read in another CSV like this one? I want to read it in. I want to get the head and I want to print out the first element and then I want to describe it. How would I do that? So I'm wanting to do the same task I've done before on new data. What would be my process in order to make that happen? I don't really think I can make that question any easier, but I'll repeat it. I have a process that I'm doing on a CSV. I'm going to read it. I'm going to get the head. I'm going to describe it. I've already done that, but now I want to do it with a different CSV. I want to do the exact same thing, but with some different data. What would I need to do in order to make that happen? Copy the previous code. Thank you. That's exactly what I was looking for. Copy the what I've done, which I know I need to do again. I'm going to copy it. I'm going to paste it, and I'm going to replace what I need to replace. Okay, with that knowledge in mind, how on earth am I going to make a data model with some new data columns I haven't used before and then plot it? I've done everything that is in here just with a different set of data. Yes, the lesson does what we want to do. So it would be in our best interest to not try to reinvent the wheel, but just copy what we have here, keep the parts we want, and change the parts that need to be different. So let's do that. There's 4 cells here. Do I need this anything from here? Do I need this line? No, I don't. What about this? Do I need this? Yeah, I'm going to be changing it. Maybe we'll start from the top and go down. It might be easier that way. Do I need this data? No, I don't need this data because I have my own data. So I don't need anything from this cell. All right, this cell is going to define the predictor function, and this is going to define the function for error. Do I need either of those? Chris says no. What are some other votes? Now, technically, you could say, no, I don't need any of this. I could write it all myself, which is true, but we don't want to do that. So in this cell, I have 2 functions. This one we've already kind of written. This one we haven't. So I would only need it if it's used. Is it used in here? Maybe, maybe not. I guess we'll find out. All right, this cell is our guessed first choices for B0, B1, and B2. Do we need this? Do we need to have an initial guess for B0, B, and B1? I appreciate the question mark. I don't know is an acceptable answer. So maybe we don't know. If I don't have something to guess with, a B0, B1, can I possibly start tinkering with them? Yeah, you could say it's silence, but it's also the same thing as not paying attention. Turn the lab on and go, I don't know, water the lawn. What I'm trying to do, keep getting rid of that one. I don't mean to. I've got a function, and it's basically, oops, I don't want to do that. Y equals B0 plus B1 X. And what I want at the end of the day, the perfect function is going to be something like, I don't know, 3 plus 9x. Who knows? Now, the way I'm going to get to 3 plus 9x is I'm going to say, okay, well, maybe I need to change this to a 2. Maybe I need to change this to a 7. Who knows? And I'm going to apply that process and see which one has the smaller error. That's how we get the line going from like that to like that to like that until we're happy with it. Now, is it possible for me to start out with nothing? Like I haven't put a single number into either of these. Can I start guessing if I don't have a first guess? The answer to that is no. We cannot start our process of guessing if we don't have a first guess. So yeah, we do need this. Okay. Now you may notice that our function only takes B0 and B1. The example and the lesson takes up to B2. So we don't actually need this part. That one I'll give you for free. All right. What about here? I'll explain what each of them are doing, and then you can just tell me if we need them or not. This part here is building that line. So the line I was talking about that would approximate stuff, the thing we need to show on the screen, this is where it's being built. So do we need this part or not? Yeah, I would say we need that. This part here is calculating how close that line is to our data. Do you think we might need that? Yeah, I do too. This part here is plotting stuff to the screen. So we need to plot stuff to the screen. Do we need the code that plots stuff to the screen? Yeah, I think so too. It's starting to look like we just want the whole thing. So that's what I'm going to do. And if we don't need anything from it, we'll just get rid of it. Okay. Alrighty. Now there's going to be some stuff in here that we need to change. Why is that? Well, as you can see, this is trying to calculate time, and it's using y equals b plus b1x plus b2 squared x squared. We don't need to go all the way up to x squared. So we need to go in here and we need to change some stuff. We don't actually need this part either. Now, what do we need to change? Well, I know that notice how we have time here as a list, and we have speed here as a list. That's because we had the data like this. We don't have the data like that. We have data frame. We have our TDA and our TPeak as our input and output, whereas time and speed were our input and output. So we just need to, everywhere we see time, we'll replace it with TDA. Okay, so let's do that. Oops. Now there's one more thing we should do before we actually can do that. And that would be to make a variable so we don't have to write the following. Rather than having to write that over and over, we're just going to make a variable for it. Okay, so everywhere I see time, I'm going to replace it. Right there. There's one. All right, everywhere I see speed, I'm going to replace it with this. Okie doke. Well, now what we can start doing is just running it and see where it stops working. Okay, we got to here. And we got this error right here. So what's the problem? Polynomial is not defined. What the heck? What is that supposed to mean? I've gotten an error. We need to change the polynomial function to TP. Yes, that's exactly right. Now, earlier when I said it could kind of go either way, what we could have done is instead changed our function to be called polynomial, or we can do it the way we're about to do it, which is every time I see this function, I'm going to replace it with this. Also, you will notice that this takes 4 arguments, and we don't take 4 arguments, we take 3. Okay. Well, let's run it and see if it works. No, but it got a little further. Okay. So SQ error is not defined. Well, what the heck is that about? Looks like I have a number and I'm trying to add something to it. What's this SQ error? It's being called like a function and I don't have one. Oh, it's another function? Is it this one? Yeah. So we need that. All right, let's run it again. Okie doke. List index out of range. Now, what that generally means is I had a list and I tried to go too far. Now, where could that be? Well, if you remember in the lesson, like I said, we went all the way up to x squared. In our current version, we're not doing that. We're going only up to x. Okay, well, let's keep going. Time is not defined. Okay, so it looks like I missed a time that needs to be replaced with TDA. All right, run it again, see what happens. Oh, hey, look at that. So we have our data, we have a model, and it is plotted. Would you say it's a good model? No, not really. What might we need to change about it? Do we need to move it up? Do we need to move it down? Do we need to change the slope? This is actually linear. No? Slope. Okay, so we need to change the slope. In which direction? Do we want to go up or down? Up. Okay. So in order to make the slope go up, we need to change the variable for B1. Now I'm only going to change it a little bit. I'm going to change it to 1, which I guess isn't really a little bit, quite a lot. But hey, look at that. We went from, what is this? 1, 2, 3, 4, 5, 6, from 8,800,000 something to 7,700,000 something. So that's progress. Is it close enough? No, I don't think so. So what do we need to change? If anything. Slope again? Yeah, probably. So I'm gonna make a go at more. It's better. You've all seen the process of what we're doing here. Basically, we're gonna move it up until it's at a point that we're okay with it. Now, I would have liked to get to the step 3, but you'll be happy to know it's the exact same thing we have going on here, except even the data are the same, but the function is different. Notice that it's y equals mx plus, or it's b plus b1 times the log of our data. So thank you to Chris especially, and the others who chimed in. I do appreciate it. I will have office hours tomorrow, and the homework is the exact same thing. You're gonna be doing the exact same thing. This is just another linear function. This is the log function. So these two are literally what we just did. And then you got to pick the one you like. Okay. Office hours, let's see, 11:30. And also I have them at 5 o'clock p.m. All righty. No, thank you. Anybody have any questions, comments, concerns before I close it down? Okay, doesn't look like it. Okay, I'm actually gonna keep it. Well, no, I can't. I guess I can't do that, can I? Yeah, that'll be it. Thank you, everybody.